And today, we will wrap up C part of the semester before we move on to things like data representation, program representation, assembly, and basic computer system. We will go with what happened when you compile, right? So anyone here ask internally, like, what happened when I run GCC? Why is there something called a.out that your computer can run? Anyone wondering that? And how does standard io.h work? How does it know what to do? How does it know how to do printf? Right? Does any one of you, when you write printf and you put in the string that you want to print on your monitor, do you have to actually control what goes to your monitor, or somehow magically something happen? So you run some function that someone already implemented before, right? And it happens. It performed that function. So we know how C code get compiled, right? You run the command gcc and you compile your program. But internally, these are some of the steps that happen. So the first thing is C will pre-process your text code, right? The reason why I say text-based code is essentially your .c file. These are texts, right? That you put in, that you declare a function, that you declare a statement. You have semicolon at the end of your statement, and C goes in and pre-process those in order to understand what are the command you want the computer to do, right? Um, then the next step, right, is to compile your program. Compiling your program kind of involves multiple steps in the middle. So step 2 is actually pretty big step, right? This is a pretty big step. And if you want to learn more, you need to take a class that dive into compiler. There are many things your computer do for performance. For example, if you write a loop, sometimes they would do something with the loop that you write, fiddle around with your code, making sure everything at the end of the day is still the same program, but now it's faster, right? That's what GCC is doing to your code, and there's many things that are actually being done right now, and there's still research that looks into how to improve this even further. Why is there still research? Because hardware change all the time. New and cool CPU comes out with new features. GCC, the compiler, would try to compile your code and use those features as much as possible, right? Then you assemble. Right? What does assemble mean? Anyone want to take a guess? What does it mean when you assemble your code? Yeah, it kind of basically the steps, right? Translate the almost like an object after you compile, right? Things would get tokenized and things would get processed and say, hey, this is an add followed by a subtract, blah 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 blah. Then you convert everything to assembly. Why assembly? That's the language that your CPU understand. It doesn't understand C. It doesn't understand your English, right? The computer understands nothing except for 0 and 1. And assembly is basically the gateway to communicate with your computer. So at the end of the day, before you run a program, everything will be converted to assembly. Then you link everything together. And we'll talk about some of these steps in a bit, right? So first step, pre-processor, what does it really mean? These essentially process information on your C code. What are some samples of the information? The header file, right? The .h file get pre-processed to kind of figure out, okay, what are the different library or .h files that I would have to put together to compile this program, because you call those functions. The pound define, we'll talk about this in a bit because we haven't talked about this in the main C lecture. And anything that has to do with the pound symbol, right, at the top, these are pre-processed. And then after you pre-process everything that's kind of like put in at the top of your C file, then it tokenizes your file. Tokenizing your file, if I want to wrap it up in one sentence, is the compiler, the GCC, go through your code that you are writing, and it try to prepare your writing in text into different tokens that can be something like A and B are the input to this adder. When you do A plus B, right? A plus B, you get tokenized into this format. I want to have variable A and B, and you want to add them, right? This allows the compiler to add the next step, like optimize your code based on this, right? Are there loops somewhere? Are there if else somewhere? What can I do? So these are being pre-processed, right? Again, if you want to go in depth on this, I don't think MUIC have a class on compiler, and to be honest, there's not a lot of expert in compiler in Thailand. I know one of my friends in Chiang Mai University. Um, I know another one of my friends at Thai SC who do GPU compiler, and that's it. Those are the only two people in the country that I know who work on compiler and programming languages. But like me and Ajahn Kanat, for example, I'm sure we taken class similar to this, so we can kind of briefly go over this if you are interested, right? And the fun part, the class, functional programming kind of talks about some of these concepts as to what goes into the language, right? So that's the pre-processing steps. What's next, right? Pound define. This is something new that I haven't talked about yet because it's not, while it's not the central part of C program, it's actually a tool at your arsenal. It's like everything that is possible to write on C code, think of it as these are your tools. So pound define, think of it as a macro, right? It defines a macro. If you want to understand deeper into what does it really mean, think of it as you replace the text in your code with whatever you define. For example, right? If I do pound define debug one, what this means is it would go through your code and check for any occurrence of this specific letter, debug, change that to number one, to the text number one. There are more examples here, but I'll show you some more fancy example of how defined. But before we go there, any questions so far? Any questions? All right. So if there's no question yet, if you have questions, feel free to type in because the next thing I'll talk about is some examples. Is it possible to you would pound define an existing test? Great question. If you pound define something that already exists, like let's say you have, I don't know, program part one dot C over here, right? And then part two dot C over here, right? And then you do pound define. Hey. And then you do again pound define, right? This is your question. Is this possible? It is similar to namespace, where in that case, over here, the compiler would yell at you and say, what should I do with the keyword hey? Because I just defined 1 and 2, and now you have two value for that name. So you cannot pound define existing term. To check if something already defined or not, you can do this. Pound if not defined, or pound if defined. So one of them would be basically check for if it's not defined, you can now define afterward. If it's defined, then you don't define or things like that, right? So you can have this if else logic on the pound define. All right, is it clear? Yeah, so this actually is really handy because once you are in a much bigger project, let's say you are trying to hack a Linux kernel, right? Anyone imagine in your life maybe you need to hack Linux kernel or like Android kernel? It can be something that you can work on, right? Let's say you get if you go and work at Google and you work in a team that work on a piece of software related to Android subsystem that has to do with anything inside the kernel, then you have to hack it, right? You might want to check if things you want to define is already defined or not, right? Uh, there's also fancy tricks that you can use with macros or pound define because it's a macro, right? So it can take arguments. So you can do something like this: pound define a b minimum, like minimum of a and b. What it does is whenever you see this question mark symbol in C, anyone know what does this mean? The question mark thing. So I can have a box, question mark, box, colon, box. Is an if else is a short form for the if else statement. So these basically mean if this bigger box. So let's say this is box X, box Y, and box Z. If X, if it's true, do Y, else Z. So the question mark thing translates to this exact if else statement. If X, then Y, else C. So you can do pound define A, B. If A is less than B, return A, otherwise return B, right? Which means that you can do min34 in your program. It basically will actually check for the minimum of the two number. Min input 1 and input 2 will check for the minimum of input 1 or input 2. But anyone see annoying thing with this pound define that can lead to more bugs? Just look at my statement up there, right? I want to use a different color. What could go wrong here? What is one easy thing that can... Oh, A and B doesn't have the type definition. The compiler would check the type when you use the number later. So that's actually one thing that can go wrong. What else? How many people get confused with a statement with so many parentheses? How many parentheses am I using here? Is too much parentheses. Yes, exactly, right? If I misspell one of them, bugs for you, right? So actually, I do like this particular page. So that you can use macro like a function, you can use macro like an object, right? And these are some of the examples. You can download the PDF on the class module so that you can click on the link. In that way, you don't have to search. But I also like this part at the end of the macro page on gcc.gnu.org. It actually have another page say macro pitfall. Don't do this. Basically, it would list out some of the things that can happen when you overly abuse the use of macro, because it can lead to bugs in your code. All right. So that's it for macro and pound define. The next thing I need to talk about is, okay, now we do pre-processing, right? The next step is you compile, right? You now have all the token process. What happened is the compiler comes in and it converts tokens into assembly. Like hopefully with optimization. Hopefully these make your code faster without you as a programmer noticing. And this happened a lot actually. The program that you compile, most of the time it's actually being done in a way that it's actually faster than the way you program it. And then afterward, the .s file is generated. Typically, this is done silently, right? You don't see the .s file. You see the .o file, right? The output of the compilation is something you can run right away. Why? Because this is typically paired up with the next step, the assembler, right? No, this is too late. This we will see that. We will see this soon. Assignment 3, assignment 4. Sorry, bugs on my own slide. You will see this on assignment 4, part B, on how to convert assembly into binary and everything. So assembler, right? Take your assembly code and convert that to binary, ones and zero, right? It converts the assembly code into binary so that your computer can now understand your code. So the .s file will be the assembly code. The .o file is just binary, ones and zero. Before the assembler step, you kind of get the .o file, right? So the C code, for example, would generate the .o file that you can run, right? What else? Are we missing anything here? The thing is, you also can do linking. Linking is when you want to build your code and you want to link also multiple files together. Because sometimes you just don't run and build one single C file, right? Sometimes you have to compile multiple files. What happens when you have multiple files? It will get compiled to multiple .o file, right? Can anyone imagine the problems here? Yes, it's kind of like the way we compile the Game of Life code, right? Where you would bundle multiple things together and you ended up with one binary that works, right? After you have multiple object file, you then combine all of them into one executable. So here's how the overview looks like. Let's say you have 3 files, right? Compile, right? Into multiple .o file. And you also can have library. What's this for? Things like printf, right? You actually run something from the library that someone defined before, so that you can utilize those predefined functions, so that you don't have to write another code to show something on your monitor. Then you perform the linking step where you get the executable. And then in many cases, you can also use a dynamic library. What is dynamic library? Anyone hear this .dll? Anyone seen this before? So if you use Windows, for example, and you want to do something odd with your games that you install, right? In many cases, let's say if I want to cheat in a video game, sometimes I need to hook up certain DLL file. DLL actually stands for Dynamically Linked Library. What are the difference between the statically linked library like this one and the dynamically linked library here? You notice the executable combine the static library already, right? Uh it's precompiled, but the dynamic library get called and get bundled and compile. Not compile, but get bundled into the executable at runtime. So it happens like when you call the function, right? The DLL file, the code there will get utilized at runtime. When you bundle the static library, it's compiled together with your code already. So it's actually a part of your executable. So hopefully it's more clear. Hopefully it's more clear that way. Basically, my executable will already have code in the static library in there. But if it call a dynamic library, you basically will go and seek those dynamic library file. It can be the .so on Linux. It can be the .ell file, right? It will be called and used somewhere in the executable. So what's the benefit of dynamic library? If someone guess the benefit? Yes, other executable can just pull from this dynamic library. But I mean, you can do the same with static library. But let me give you one scenario, right? What if I update certain firmware that update the DLL file? If I run the code after I update the firmware, will I see the newer version or am I gonna see the older version? You're gonna get the newer version of the library, right? This is one of the benefit of the dynamic library. What's the downside? And what's the downside of this? Just think about it. It possibly can break execution. Can anyone run games and then it just simply crash and say you cannot find that .dll file? Like the library is just missing. It's not on your computer. That can happen, right? Because if you use static library, it's a part of your executable. So whatever you run, it would work, right? For the dynamic library, you also need to guarantee that it's there. Otherwise, your executable would break, right? So that's the trade-off. You can update the new version, but then you also lose the ability to be a standalone executable. It rely on this library. And imagine, for example, you update a computer from Windows say 7 to Windows 10. Imagine the headache, right? So actually, if you think about it that way, anyone here try updating Windows 7 to Windows 10? I'm gonna go off topic a little bit. Anyone did that before? Yeah, so if you went from 7 to 8 to 10, right? Did you realize that the steps is actually easier than back 10 years ago when you had to upgrade, say, Windows XP to Windows 7? It is more user friendly in the sense that somehow many other things kind of work. Do you realize that? Like many of the things you install. Oh, you're too young to know. Good thing. That's a good thing to not realize. That you have to kind of reformat everything and then install every single thing. Yeah, we all use those CD thingy. You don't use that anymore, right? I mean, I don't use it. I have this DVD drive here. Yeah. So do you think it's brilliant that now you can update Windows and your effort is to click install and it work? It work even when you have these whole thing to think about, right? So that's actually a big effort, right? It does work much better, right? But it does take a lot of effort from the system design on how to make sure that I changed a lot of the kernel code, right? But everything was still working from the assumption in Windows 7 to the new assumption in Windows 10, so that the user doesn't have to feel the pain of many parts breaking and I have to reformat and install everything, right? I was surprised actually when I upgrade my desktop from Windows 7 to Windows 10 that it's actually this easy. Yeah. So let's do a quick recap on library. What about today, right? Uh, so what do we use library for in real life? Convenience. Be more precise, I guess. That's too vague. What do you need the library for? It's a place with lots of books, right? Why, and what do we use those books for? To get information, right? Think of it as it's a reference information for you to refer to. It's knowledge, right? It's teaching you how to do certain things, right? So library in computer serves the same purpose. it allow the computer to say, okay, this is how you do X and Y and Z. So if someone asks in the program, right, and then you forgot to return the books, that's not the computer problem, I guess. It should return, actually, even though it's share, right? In many cases, it will return the book. But if you think about it, it's the pile of knowledge on how to do certain things. For example, you can have a C standard library where you can have the book that tells the computer how to printf, how to do scanf, how to do the absolute, how to do quicksort, right? So these are pre-implemented and installed. Whenever you install the library, it will be on your computer, right? And because we know how the Linux work, as long as you have the path available for your computer, right? When you compile your code, it knows exactly how to find standard.io.h and standard.library.h, right? So that's path variable will tell you where to go. So you have a static library where you link the library code at compile time. So when you compile your C code, the object file along with the library file would get fusion together and you generate the executable. As I said, these allow you to use the library code as a standalone executable. You don't have to kind of always bring the library with you. Now, dynamic libraries is quite interesting in the sense that instead of linking them at compile time, you link at runtime. The meaning of this is you perform the link operation right when the executable is run, right? You need to make sure, for example, it's there when you run it. You need to make sure that in Linux, you want to make sure the path is in here. These are one of the common paths for your dynamically linked library. When the linker adds a library, does it compile all the function library just one? No, just the one used for your code, actually. And this DLL typically is also pre-compiled, right? So that it know how to call the function. It's not it's not like when you run the function, the compiler kicks in and compile again. Actually, it just link the two together. There's also shared library, something in Linux we call the .so file, right? These are the object files that can be shared across multiple programs, where each program can use the library, and loading this .so would be done at runtime. GCC also comes with multiple optimization flags that I recommend you to try, actually. So by default, your code is compiled and optimized. Depending on the version of GCC, to be honest, sometimes it's actually not optimized. Um, there are multiple level optimization from O1, O2, and O3. Um, please make sure you don't have undefined behavior of weird things on your code before you use O3. O3 is really, really aggressive, but can make your program really, really fast as well. The dash OG would do optimization with debugging, right? And you can take a look at this GNU.org that lists out. It's up to O3. Why not use O3 all the time? That's a great question. Uh, there are certain optimization, for example, that get published in research, and then okay, these are cool. Let's put it in GCC in the dash O3, and sometimes they have like let's say you have weird, really, really, really weird corner cases. Some of these are experimental, so I would say O2 is really safe. Actually, O2 is kind of known, right? O3, some of the even non-experimental additional optimization make some assumption about your code, where 99.99% of the code in the world would work. It just not want to make sure it's not that 0.01%. All right. So that hopefully that answer why not use O3 all the time, because um, especially for people working in compiler and programming languages, 100% accuracy is really important because you want to make sure the compile code reflects the program, right? if the programmer has bugs, the compile code should have the same exact bug with the exact properties, right? If they don't have bugs, it also need to make sure there's no bugs there, right? There's also like another set of techniques to kind of work and compile your code and detect bugs, right? That's why GCC spits out warning and everything. Do we still need dash G when? Oh no. So if you do dash OG, that's already okay. All right. So one example of the optimization that's done is called inlining, right? So when you call a function, and you will know more about this in assembly, where you create a function, it actually create a bunch of things on the stack, right? So this thing takes time. Instead of creating a function, you can use inline function. Inline function is basically, let's say I have something like this. Int add, int a, int b, right? Return a plus b. And then in the main function, int main, right? Add 5 and 4. Inline function would plug in this a plus b inside the main function so that you don't have to call the function. That's faster, right? So you can enable the inline function flag. You basically copy the code in the function and paste it in the caller. Uh, and you can also use the word inline, the keyword inline inside C to do that as well. You can turn on the optimization flag that would enable this small function that's really cool. So if you look at this, right, this link, so see if I can click on it to go there. Nope. I'll show this on a demo, actually, the optimization flags and what are the things that you can do. In the meantime, let's move on to Makefile. So that's something that you have to deal with in assignment 3. We'll give you the Makefile and it will work. Before we go there, let's do a quick break. How about the 10 minutes break? We'll resume at 2:58. Is that okay? In the meantime, type questions on the chat. I'll answer them. But we'll do a quick pause so that you can catch up and ask any questions that you might have. All right. Okay. So what is a makefile? Anyone seen that before? It's a file literally called makefile. So when you look at a complex C program, right? Sometimes you can have .c file everywhere, especially if you work at a big company, right? There can be multiple teams working on the program for different features, and to be safe, they don't share a lot of common file. They would just build their own features and they push the updates to the main if you use Git, right? The main Git repo, right? And building a complex program that has a lot of components can be complicated, right? So Makefile is your tool. What it does is it's a directions to build a program. You can declare the requirements. These are called prerequisites, right? You can also put in put in a set command for each target. The target is the file that the Makefile will create. So it will create the file after running the command. So the format is this. You have things like prerequisite, you have the target, and you have the command. So to put everything together, right? The format is target colon prerequisites, and then followed by the list of command based on each target. We'll go through some examples so that you see a better clear example on this. First of all, what goes into the command? any shell command can go there. You can make a new directory, you can create a new file, you can just echo to print something out. You can compile your program using GCC, right? It also have variables, so support. It does support variables similar to shell. You can use the $sign variable name as a variable, right? You also can have phony targets where instead of creating a file list in the target, it doesn't create anything. For example, if I want to build a phony target that instead of creating the file, remove every object file, .o file that my compiler generated to clean up, like basically to do the reverse process of compiling. So you want to remove the binary, you want to remove the .o file and leave just the .c file and .h file. You can do phony, right? Typically there will always be the clean target. Clean target allows you to type in the command make clean. So the command make will invoke the make file in that directory and it will follow the target here, right? This is the target. So it would invoke whatever is in the target called clean, right? And here you say, hey, phony :clean means that if I have a clean target, it doesn't generate any file. The only thing I do is to remove anything with the .o file extension. You can also use wildcard, right? If you use stars.c, basically will apply all the command to all the .c file in that folder, right? You can also do make all. Make all will use all as the target. Typically inside the make file, there'll be another target called all, where it combines multiple sub-targets, like target 1, target 2, target 3. This will get run as if you are running the first target, followed by the second target, followed by the third target. For example, you can have the all, which is test 1. And then over there, later, you have a definition for target, test 1, and debug 2. So this part after colon would be the prerequisite file. Basically, these are lists of files needed for test 1. Again, this is prerequisite. It basically will list file, right, needed for this new target, debug 2. So if you run make all, you would first do test 1, then debug 2, and then do all the commands in here, then in here. If you do not have file in the prerequisite, what would happen is Makefile will not compile your code. It will say, hey, that file is missing. Go and fix it. It will tell you that something is missing, so you can go and fix whatever file is missing. You can also specify the compiler, because sometimes it's not just the GCC. Sometimes you want to use a different version, for example, for the C compiler. If you use Mac, for example, it has another different compiler for open source compiler framework called LLVM. So the compiler for C is called CLang. In that case, you can set the CC flag to be CLang, right? So that it compiles using CLang instead of GCC. You can also specify the version. For example, you can say CC equals GCC. This basically means use the default version. Or you can say GCC-4.4. This would use GCC version 4.4. If you have C++ in the in the code, then you can do CXX, so that's C++. And then you can do CXX equal G++. G++ is the command to compile C++ program. This is C++ compiler. Again, you can do G++ 4.4 to make sure it compile anything that has the C++ program with the 4.4 version or CLAN, right? I'll give you one example, right? There was a time I worked with my own code, but some of the code are from someone else and it's old. It only worked with GCC version 4.4. But then my own code is on C++. But I need version 5.4 or better or newer to compile. So what can I do here? So now I need version 4.4 for C and version 5.4 for C++. What can I do in the Makefile? Yes, in this case, CXX is basically a variable, but inside Makefile, typically we would assume that this is essentially the compiler for C++. So in that case, what should I do? I can do CC equals something and CXX equals something, but what should I put in here? How do I get the version 4.4 of GCC? In the Makefile, right, I can do GCC-4.4 and G++-5.4. So that when I use this Makefile on my code, it forced the Makefile to use version 5.4 for any C++ file, and then use version 4.4 for any C file, right? So I can do that too. I can also specify compiler arguments using C flags. C flag can be something like -G. This would enable what? What does -G do to GCC? Anyone remember from the demo on Tuesday? It allowed the use of GDB, right? Now you can debug your code. You can also put a flag for C++ based code by using CXX flags, right? So you can also do the linker, right? By typically these linker, you would just do the -LD. So these are the load flags. It set the compiler in case you need to load any linker. You can also use conditional like if equal or if not equal, EQ, not EG, sorry. This is handy when you want to say compare user ID or system specification. I have been using this to check if the version of the compiler is the one I want or not. If this is the user that allowed you to run the Makefile, I can use the if else to make sure it install the program at a different folder based on my condition, right? You can also make the Makefile calling another Makefile. You can use the command export to transfer the variable to another Makefile. So you can export the variable into the different Makefile. You can call another Makefile within one Makefile. So you can nest up the Makefiles together. While not recommending, sometimes you have to do that because say you download a different set of programs, right? Then each program would have the Makefile, and you have the parent directory that goes into each of these programs folder to install everything. So the big Makefile would go and call each program's Makefile. Any questions? So that's it for the lecture part today. We'll move on to the Q&A. Any questions about the lecture today, or any questions about things that we covered so far? We are done with the lecture. the next thing that you should do is assignment 2 and in class, I think in class 7, right? If I remember correctly, it should be at in class. We should be at in class 7. So now I'm gonna open the floor up for questions. The other thing that I will do if we have time, we will finishing up the metrics add example, and we will go over what is going on when we use the statically defined metrics. All right. Oh yeah, the linked list example, I'll do that too. I forgot. I'm sorry. I totally forgot. So we'll do two things. Linked list. And then the metrics app. So how about this? We'll do a 10 minutes Q&A until there's no more questions. And then hopefully by maybe 3:25, we'll move on to the demo again. I will pause the recording for now so we can, for those of you who want to take a break, you can take a break. If there's any interesting question, I'll resume and then I'll iterate the question so that if you watch the video, you can see you can see the questions afterward. All right. So we'll leave 10 to 15 minutes for that. Otherwise, it's a break for you guys. So there was a question about what's inlining, right? So let's say I have some function that do x plus y, right? And then I have another function that call func 5, 10, right? Inlining basically, instead of calling the function, if func is an inline function, you replace the function body with x plus y. And because you know the input is 5 and 10, so for x is 5. Oh, sorry, it's definitely not a good color because it's too bright and you can't see. X would be 5, y would be 10. So it will replace that line function call with 5 plus 10. So that's why we call this inline function. You copy the function body and put it inline. Is it more clear now? Sorry. Me too. That's why I realized that it's not a good color to put on the screen. It's like no one can see. But is it more clear? Basically, you copy the whatever goes in the function, paste it in the function that call it, and then replace the variable input with whatever should go into the input. All right, if there's no more questions, I will first of all switch over to my desktop so that I can share my screen. Hi, Jack. Here. Do you see my screen? Okay, so we will resume the example in 5 minutes. Let's give everyone a 5 minutes quick break. Okay, now let's look at the code with this new printf. %x is basically printing out hexadecimal number. And let's run. Obviously, this will go, something will go wrong here, right? but let's try it anyway. And let's set a breakpoint at line 6, where you just call the function metrics add and run. These are the address that we want. Right? These are the address that we want. This is A. This is also A00, right? These are correct. The address of A00 should be the same as the address of A. Basically, it's the address of this number. This is A01. So that's the next element. Again, integer is 4 bytes. So as you can see, it's +4. This is A10. And A10 is 234. So that's +16 from 2 to 4. And then 238. So that's A11. So this is A10, A11, A00, A01. These are all the address. Basically, it's the address of this number, the address of this number, the address of this number, and the address of this number. A is our input 1, right? Is our input 1. So let's print input 1. See something that solve. So let's first step into the loop. And then print again, print input 1. Right? Why is this the case? Why is this originally 370 and now it's get initialized again to 220? So the first line, line number 6, is our function call. We haven't even entered the function yet, so that's our random number. It's our random number. And then you assign A to be input 1. So now you see, right? A, FFFFE220. Input 1 also FFFFE220. That looks okay, right? That looks okay. What if I want to print this? Oops. This needs to be input 1. I try to dereference input 1 using that address 220, right? And what I get is another address. Because why? Why? What is the type of input? Sorry, what is the type of input 1? Is pointer to index 0. How big is the pointer? Pointer is 8 bytes, actually. That's why your address is this long. It's actually 8 bytes, right? But now, this is one number. This is one number, right? So I'm trying to dereference a pointer. But if you look at the address when I create the array, the first item is at 220. The second item is at 224. You see, that's 4 bytes. I'm trying to dereference something that's 8 bytes in size somehow, right? In order to get the number 1112 here, I don't need 8 bytes. I need 4 bytes. How do I do that? So if I do print star input 1, it tries to dereference 8 bytes. Yes, exactly. You then can cast this to, it's an in pointer, right? So if you want to dereference it, I want just 4 bytes. Magic. If I just take 4 bytes from input 1, now I got the correct number. Now, what do I do next? If I want to do, let's say I want to do input plus 1, input 1 plus 1. I got to 8. 2 to 8. Too far, right? Because my second element is not at 2 to 8, it's at 2 to 4. 2 to 8 is already here. I want to get here. What do I do? Cast again, right? Input 1 should be, yes. Now I get 2 to 4. So if I have this and I dereference the whole thing, I now get 150, correct again, right? So can someone summarize the problem we saw last week? And not last week, on Tuesday. Do you mind if I go back to the code so that we can point out the code? Yeah, it's type mismatch actually, right? That's why the compiler, when you compile, right, it gives you tons of warning because you are trying to, it's not expecting int star star because it's a static array. It's a static array. And if you just run, right, this is the address that you print. You see that this is this number, right? This is also this number. The number next to it is this plus 4. This is basically the 1112 plus 20. This is 1112 plus 24, right? It's 4 bytes each for each of these box. And if you look at this whole thing here, this whole thing, right? This whole thing, it's just a flat. It's just a flat area where the first number is 4 bytes from the second number. So each number here is get incremented by 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. So one thing I can do to fix this, one easy thing I can do to fix this, I would treat every one of my input as just a pointer to a number, right? Now my input 1 is a pointer to a number. Input 2 is pointer to a number. And then when I do this, is I times size of x. So basically I want to flatten from 2D to 1D, right? And then input here, input I multiplied by size of x plus j. Similar thing here, input I multiplied by size of x plus j, right? And then I have only one-dimensional input. What do I do here? What do I do here to get it to the correct data type? Remember, A is just an address, right? A is just an address. I can just put in the value, and as long as it's treated as one single address, I'm okay. So I can cast this to int star. Right? Let's compile and run. Now it works. Why does it work? Why does it work? Despite all those warnings. So one thing you can do is you can see all the warning is about my printf. So I don't care about those, right? If you want just warning, you can do ampersand redirection to the output. This would give you a standard error from your monitor to a file. So I can get rid of all the warning by just do this. It's all just that one line. Now it's typecast to the type that I want. I want because when I create, right, when I create this array, remember our lecture on Tuesday? 2D array statically defined is just a one flat 1D contiguous array, right? It's a contiguous array. It's actually, if you think about it, it's just a pointer, one level. It's not double star, it's just one star. But if it's 5 by 5, that one star covers the range from 0 to 24. It covers the range from 0 to 24. So what you want to pass in is where's the starting point, A, B, and C, right? And then you cast it so that the size of the pointer match with the size of your data type. All right. So that's how you can fix it. All right. So any questions about this before we go to linked list? Oh, is there a reason? Okay, that's a great question. So if you think about int star pointer, right? Why is this 8 bytes? What does pointer point to? This is essentially pointer that point to another pointer, right? That's why it's 8 bytes. Because a pointer in a 64-bit machine is 8 bytes. Because the address of, at least within the Intel 64-bit architecture, an address is 64 bytes. 64 bits, sorry, 64 bits long, so that's 8 bytes. Now is it more clear? There's another question. What is %x? %x, so %d, decimal, %x, hexadecimal, %s, string, %c, character. So you can check out the format string and see what are the different formats that you want. You can also do %f, floating point. It allows printf to treat the correct format. Yes, actually, it's actually way more complicated than just that, right? 32-bit downloads surprisingly actually would work on a 64-bit architecture, because the 64-bit architecture that AMD designed is designed to be backward compatible with 32-bit machine. You might even go side topic on the history of the AMD 64-bit architecture. This is quite an interesting story on this. Let me switch back to my desktop screen. So do you see my blank slide? So there was a certain time in the early 2000s, right? Where, say, you have DRAM, right? The size of your DRAM back then was like 1 GB. Then you have machine that have 2 GB, 4 GB. And now these days you can have machine that have 64 gigabytes or more, right? If you look at the 32-bit machine, if I can only represent an address with 4 bytes long, I can go up to 4 GB. There's no way I can represent anything beyond 4 GB because I don't have the bits in the address to represent more, right? So what would be the solution? Over here, right, address is 32-bit long. If it's 32 bits long, you can represent an address up to 2 to the 31 minus 1. This is about 4 GB of memory. Now you have DRAM that are bigger than 4 GB. Plugging that on a 32-bit machine, you can only go up to 4 GB at best, right? Would that be bad? How many computers only have 4 GB of memory these days, right? So both Intel and AMD back in the day was like, okay, this is definitely the problem because we want to support bigger DRAM. That's one of the big benefit, right, of the 64-bit architecture. But I mean, if we're gonna come up with a new ISA, a new instruction set architecture anyway for 64-bit support, right? Why not make it better, right? So Intel and AMD have researched into their own version of 64-bit machine. This one is Titanium. This is called AMD 64. If you follow technology news, one thing about Intel Titanium is if you want to run this on a 32-bit, the program that are written under 32-bit machine using 32-bit architecture and 32-bit ISA, it won't run. The reason behind that is this thing does not support 32-bit x86 instruction. But the AMD 64 actually do support, right? Support 32-bit x86 instruction. Actually, a lot of awesome thing from the Intel Titanium design, but it doesn't support any program compile with 32-bit x86 ISA, which is essentially any program written before 2000. So if you want to sell a computer in year, say 2004, what does it mean? What does it mean? You need to basically, if you want to use Intel architecture, right, for the 64-bit ISA, you then need to make sure your program support this Intel 64-bit architecture. You can emulate. That's a great answer. By the time Intel came up with a good way to emulate 32-bit x86 instruction, the whole market already used AMD 64, including Intel chips. so basically they're too late. Um, our 64-bit x86 architecture, there's a reason why if you download say Ubuntu distribution and say AMD 64, it's because of it's actually invented by AMD. And Intel use it now on their x86 chips as well. Because it does support 32-bit program that are written for the old 32-bit architecture back in the year 2000 and earlier. So that's why I said, hey, I want to share this interesting history. uh, it's important when you want to design things that can impact. It is relevant. Again, as I said, Intel Titanium architecture is actually really also it's quite well designed. There are certain server that still use them. AMD 60, yes, AMD 64 is the name for the ISA. So I have a quick question. Should we leave the linked list example for next week or what? Should we go through the example now? I can probably power through that, but we only have 15 minutes, and I want to make sure you're not late for the next class. Broken pipe. So for the linked list, I will do something simple first, and we'll go based on how much time we have left. Yeah, we can go in depth in the next class. How about this? So we can basically what's in the linked list? A node, right? As we said. So what does the node have to have, right? There are two things. This is your data that you want to store, right? And the second thing is this is basically the pointer to the next node, right? That's it. Basically, I have a data and a pointer. And because I'm lazy, I can do type def struct my node. Why do I do this? Because in the future, if I want to create a node, I can just do this. This is equivalent because I do type def, it basically replaced the data type called struct my node with just a simple 4-letter node, right? Now I want first to basically point to the first element in my linked list. So if I want to print everything in my linked list, right? One thing I can do is I can loop, right? I can loop for, what do? I would just first point to the first item, right? What should I do next? This is not now, because if it's now, I'm gonna get segfault, right? And then I would basically just do printf, right? Notice how I use this arrow sign. This arrow sign is the same as if I first dereference temp, right? Because temp is a pointer. It's a pointer to struct. The first thing I have to do is to dereference them to get the struct. And then once I got the struct, I'll just do temp.next. That's a short form in C for the where you use an arrow. It's the same thing. Right? So now you print the first element and then you loop in, go to the next element, you print, keep printing until you're done. And just for making it look nice, I will just do /n at the end. So I'm done with printing. How about insertion? So let me do this. I want to create a function called insert at, right? I would insert at the index. So if index is 0, I insert at the front. If index is 10, I insert at the location index 10 or at the end of the list if it's less than 10, right? What should I do here? What should I do here? I can do this, right? I can definitely do this. I go through my list, right? I loop until temp is null, or I keep looping when I can keep going. And also what? I want to make sure it's less than, right? Because I want to keep going. I want to keep going. So we can keep going, and also counter is less than index, right? Counter and less than index. So basically, this is the location I want to insert. Why is it or? So what would happen if I do or? We need to stop the loop when counter is equal to index. So if counter is equal to index, what is this statement? Is it true or false? If counter equals to index, is it true or is it false? it's going to be false, so it will stop going. That's where we want to stop. So if counter is equal to index, we stop. Or we stop when? When is this going to become false? You're at the end. We can't go anymore. Right? We can't go anymore. So are we good here? Yeah, this is the same as counter is not equal to index or temp is null. Temp is null. Remember logic A, not of A and B is gonna equal to not of A or not of B. Okay, so do we have to do anything inside the loop? Let's keep something like this for now. And you'll see why soon. So let's say we are here, right? A, B, C, and D. And we want to insert here. So we want to insert an index number 2, right? We want to insert an index number 2 where are we stopping right now? What is temp pointing to? It doesn't point to a new node. Temp point to, it basically keep going next. So let's say index equals to, how many times will this go? The first time temp points to A, right? The second iteration, temps point to B. The third iteration, temps point to C and it stops, right? Temps point to C and it stops. Well, we will get there. We'll get there. So now we are at node C. So basically, temps point to C. I forgot to do this. Sorry. Are we all with me? Basically, right now, temp points to C. What does temp2 points to? Now, it should answer why we need temp2. Temp2 points to B. Why do I need temp2 then? So that we can make sure that B can point to the new node we are inserting, right? And also I should initialize this to now. So what do we do? Now that temp2 points to B, temp points to C, we want to insert after B, right? So what do we do? Sorry for the overused word temp. Oh yeah, if you need you to go, you can go now. I will go back again. I will come back again next week. Now we have temp3, which is a new node we want to insert, right? Temp3 I equals data. Temp3 next equal what? What is temp3 next? Should it point to B or should it point to C? C, right? So this is temp. And then temp2 next, which is B. B next should point to what? This is basically B next point to the new node. This is the new node. Next point to C. And now let me put this in the comment so to make it easier to read. All right. Quick question. Last question. What if temp2 is null? What will be the problem here if temp2 is null? Can I do temp2.next, or am I gonna segfault? I will segfault, right? Which is bad. So I don't want to segfault. If temp2 equals null, what's the only situation temp2 becomes null? We want to insert at the front, right? So now first equals temp3, our new node, and then temp3. Oops. First, I want to make sure temp3 next point to for the first element, and then the first element point to the new node we just insert. All right, so that's how you insert using insert at. Hopefully this is correct. I'm actually not 100% sure. I think it should. We will go there next week. All right. So I'll clean this up a little bit. We'll go there next week, and we'll do deletion as well. Yeah, I know this go too fast, and I'm sorry. Next week when we review, we'll go slower. Okay, so let me save this. Stop recording as well. Where's the file located? I'll show you soon.